hate people.
Yeah, sometimes you do. A little lazy. Hello everyone. July 13th. 2 tough questions in a row. Actually, yesterday was not that bad. Yesterday was not that bad. Number of atoms. Given a string formula representing a chemical formula, return the count of each atom. The atomic element always starts with an uppercase character, then 0 or more lowercase letters. I don't even remember atom anymore. One or more representing the name. One or more digits representing that element's count and may follow if the count is greater than 1. If the count is 1, no digits will follow. For example, H2O and H2O2 are possible, but H1O2 is not possible. Yes, the two formulas are concatenated together to produce another formula. For example, H2O2, He3Mg4. That's magnesium, this is helium. Is also a formula. A formula placed in parentheses and a count optional added is also a formula. For example, this and this are formulas. Return the count of all elements as a string in the following form. The first name in sorted order followed by its count. If the count is more than 1, followed by the second name, followed by its count, and so on. So H2O is going to be H2O. This will be H2 magnesium O2. This is going to be, oh my goodness. Let's try this out. I think this is also stack, right? So we have K. What's K? Potassium, right? K4 O, that's oxygen, nitrogen, sulfide, oxygen. All right, so basically we have to expand it. So we have K, we probably know the 4, and now we have a left parentheses, so we don't worry. We have O. Wait, cat O is, ooh, holy crap. Okay, no. So O and, because when we have left parentheses, yeah. Okay. Parentheses S O 3 right parentheses 2. How do we do this? Because O3 all right, can we do yes, I think when we do this, it's going to be an array. Okay, so we'll do a little counter. So this is actually going to be O1, N1, S1, O3, right parentheses, right parentheses. Hold on, let me think. If you have right parentheses, all right, so it will be very, I don't want to say very easy. Counter, can we use counter, a map? Yeah, I can do a map. Can I do a stack? Actually, I'm not sure. In Java, can I do a stack of map of integer and integer? I think I can. Yeah, I'm gonna do this. So every time when I hit a right parentheses, I will pop everything in here and create a new map. Create a new map. No, I don't want a map. I want a stack of int. And this int is 26 in size. So I use that as the map. I think it will be faster, right? And when I hit a right parentheses, yeah, let me redo this part. So K, I'll push it in, right? It's gonna be this, at the k position, it will have 1, and it will have 4. Then we go to whatever is the previous, and then we change into 4. So this one basically is this, and I will put it back in. So we pop it or put it back in, and left parenthesis. What you gonna do with left parentheses? Shoot. Left parentheses. It's not gonna be on the stack, mind you. It's not gonna be on the stack. But we need to put it on the stack. Crap. Do we have an ASCII table? You right?
Yeah.
Awesome. Where is the left parentheses? Ugh, that's... Okay, so I'm gonna create a 26 in size, so I can mark this. Okay, I can mark this. I'll put on the 26. Oh, 27. The last would be the left parenthesis. So we put that in, and we have O. We have N. Again, left parentheses is 1. Right, and then S, O, 3. Pop this out, turn into 3. And then right parentheses, then we'll pop this, right, consolidate, pop this, consolidate, pop this, stop. Now we have 1 with S and 3, push it in. Now this is going to be 1, and then 2, so S will be 2, this will be 6, right? Right parentheses again, so we'll combine these, so we'll have S is 2, N is 1, O is 7, right? This will be popped, and then 2 comes in, so this will be 4, 2, 14. So done. So we at the end, now we go through everything. We go through everything. Actually, no. Yeah, we go through everything. So we at the end we'll have, you know, K is 4, N is 2, O is 4, S is 4. So we're gonna output K4, N2, O is not 4, O is 14, and S is 4. Yep. We can do it. It's actually not that hard. I think, yeah, it's not that hard. You just need to find the right data structure, which I think this will be a good question. I think this will be a good question, right? So we need a stack. Int, call it stack. Okay, so what we're gonna do is for string f of formula, right? And then what we're gonna say is so if it's, holy crap, how do I tell if it's a number? If it's a right parentheses, yes. If it's a left parenthesis, okay, let's just one by if. That's actually not true because, yeah, it's actually not true. It's not this. All right, this should be a char dot to char array. Okay, if f is equal to a left parentheses. Okay, what do? We say stack int temp new int 27 temp 26 go to 1 stack.add temp. Right? Else if f is equal to right parentheses. Alright, we'll handle this one later. What else? If it's a number. Else if f. Oh shoot! Could be multiple numbers. Damn. Okay. Okay. Holy crap. Yep. Okay, I see how it is. I see how it is. There's number. Holy crap. Because number we need to. Oh my god. Oh my god. Okay, so this is a, oh my god, this is gonna be a very tough way to parse. So we need to have element, right? We need to have element and keep that one going. Can we get the element out? How do we get element out? Exactly, how do we get element out? So as we go through, so element always starts with uppercase. And then go to lowercase. So which means we have an uppercase that's the start of a new element. Alright, parentheses is easy, okay? So what we need to do now is to identify the elements. So the elements is when we hit an uppercase, we record the element, right? We record. Then that one doesn't even work anymore. You can't even use an int. Gosh. You have to use a map. Because the element, yeah, N is nitrogen, right? Na is sodium, right? So like, how would you represent Na? So we need a way to identify the current stuff, right? So if it's yeah, it will just keep going until you hit another one, then you have the previous one put it into it, right? Or you hit a number, but you hit a number, you cannot put the previous one into it immediately because you can have, you know, like the hardest stuff to do is like say Na12. You have 12 sodium, so you need to have something keep track of sodium and have something to keep track of this, right? So the only thing that indicates, so you have to keep, if you see a uppercase letter, you put it into a temp, and if it's followed by a lowercase, you always just add to it, and it become a string, right? It kind of become a string. So use a string builder for this. And once you hit a number, you do a number. Once you hit a new uppercase, you handle this. Once you hit, okay, how do I check if it's uppercase or lowercase? I hope there's an API for this. Let's say Java check. Well, I guess I can check. It's just ASCII, right? It's just ASCII. Yeah, it's just ASCII. Okay. All right. Oh, this is gonna be very fun. Oh, I like this problem. I like this problem a lot. I think we have to do a map, unfortunately. A map of string and integer. Okay, so yeah, so we need a string builder. Current atom oh shoot. Already a newest change? Really? String builder current atom equal to new string builder, and we need to say int count 0. Okay, so when we start, if f is larger or equal to a, enjoy, and f is smaller or equal to z, easiest case, okay, then we just say current atom dot append f, done. Else if f is larger or equal to a and f is smaller or equal to z, okay, in that case, whatever the previous, we have to handle it. How do we handle? We will say whatever that is previously will be created into a map, and we'll put it into the stack. So we say map string integer, right, temp new hash map, and temp dot put string is going to be current atom dot to string and count, right, whatever count we have, and then stack dot add temp. Okay, right, we add this temp, and then current atom dot clear. Oh, do we have clear? Remove? Oh my goodness. Reset Java string builder clear. Set length 0. Set length 0. Current atom dot append f count equal to 1. Right, we reset. That's if we hit this. Fair enough. But what if if current atom dot length is larger than 0 and count is larger than 0, then we do all this. Right? Because if it's not, actually these shall do here. Right? We have atom, we have count, then we handle this, and we do the current atom, we'll add it. So we'll reset current atom in this, okay? Else if Yeah, left parentheses. If f is equal to left parentheses, that means whatever the previous one need to be handled. Right? We need to handle it, which means we're calling the same. Huh. Right? We're calling the same thing. Because the left parentheses, whatever we have previous, we need to put them together. And then push it in. So I'll say okay. But how do I get count back to 0? We'll just call it. Update. Now I think for the current round, I'll just copy and paste. I think it's easier to do. Right? If there's left parentheses, we'll do exactly the same thing, but at the end I'll set. Actually here I'll set count equal to 0. Right? I mean you can say we can set count equal to 0 here as well. Help us refactor later on. Left parentheses, we do all that, and we say can we initialize hash map? Entry map.off. I have no idea. Put. Map.off. Okay, I'm gonna try map.off. Map.off current atom.toString count. Right? Data. Key value. I just have one key value pair. So now I don't need these two. Okay, here is the same. Map.off current atom string count. Oh shoot. Add this, okay. But either way, here we're gonna say stack all right. Map of this, because it's a left parentheses, we need to mark it. Right, you just update a count. If it's a number. I think this should be 1 all the time. I think this should be 1 all the time. I think this should be 1 all the time. Because sometimes you don't have it. So immediately do the other one, you have to get a 1. So when you hit a number, right? When you hit a number, if it's a single number, holy crap. Holy crap. No, undo, 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 undo. All right. If we have this, that doesn't matter what this is. Doesn't matter what this is. As long as we have this, and this will be count larger than 0, we'll do count. Otherwise, 1. Reset. Okay. Then we do this, we set it to 1. Actually, we always set it to 1 here. Let me think again. So we already set it to 1. So we hit we hit a number. Yeah, we hit a number. That is gonna be different. We hit a number. Yeah, we shouldn't. We should not set it to 1. All right. We should not set it to 1. We shall set it to 0. And then when we hit a number, it depends. If the previous number, okay, so if the count is 0, the count is equal to 0, then we do 1. Otherwise, we do this. If count is 0, which means we don't have any count before, actually not 1. What I'm trying to say is going to be f minus 0. Plus, okay. Oh yeah, I think that's right. I think that's right. So if count is 0, then we hit whatever the current f is, right? Otherwise, there's no otherwise. If count have a value, then you'll just keep going. So the first one comes, so always be that. And if we have a value before, we add another one, will be this. And then we'll worry about this like in here, right? This is where we worry about it. This is what we worry about it. If it's 0, we'll count as 1, which means we don't have anything. Okay, so the last one is, I think this is the one. I think this is the one. This is right parentheses. All right, so when the right parentheses comes, ooh, hold on, hold a second. If the left parentheses come, damn, if the left parentheses come, if I have previous, right, if the left parentheses come, if I previous have a number, so always put a map into the stack. Always put a map into the stack. So when a number is finished, yeah, so we keep counting number. So the first one, when a number is finished, the first one shows up can be a right parentheses. Because the right parentheses is ending, so what will end? Left parentheses will end. Right parentheses will end. And a capitalized letter will end. They will all end the previous. Therefore, holy crap. Okay, I need a better analysis of this. All right, so the possibility is lowercase letter, uppercase letter, left parentheses, right parentheses, and a digit. All right, this is easy. This is always a pen. We handle this. This can be a star. So before a big A, it could be a this, which shall be handled by this already. So this we don't have to worry. Or it can be a number, right? It can be a number. So that we need to handle. Or it can be a lowercase, right? Or it can be a left parenthesis. We don't have to handle a left parenthesis. We don't have to handle because this one's already pushed in. Okay. So this is handled. Of course, right parentheses, this one also handled. So we need to handle this. A digit is, if we have a digit, and if we have the current handle is we have a digit and we have an atom. We have the current atom, then we'll push it in. All right, that's if it's a digit. If it's an atom itself, then atom length will definitely be larger than 0. Then we'll handle it as well. If the right parentheses will guarantee that the current atom was set to 0, that's actually fine. Right? Now left parentheses. Now if it's a left parentheses, we'll have previous can be 0, can be a digit, can be a that. That's the thing. That is the thing. Because the previous can be a parentheses, right? It can be a parentheses. You know what? I think it'll be easier if we turn the formula into a list of strings. Right, we get every element out, so we don't have to handle it. We don't have to do all this if and else, right? We just handle it first. Left parentheses, we'll put it in. Left parentheses, we'll put it in. Everything is a string, okay? Everything we go as string. We turn this, we break it down into each component, and then we use a stack. Then it will be much easier to handle. So every time we handle it, every time it's a number, we'll handle it. Yep. That's actually easier. This is getting a little bit too heavy. And the stack is fine, but we need a list of string components, comps. Okay, this is fine. We'll do this. This is fine. And if it's this, we still have to handle it, right? But it's just if it is a right parentheses. No, if it's a... Yeah, I'm just wondering, do we even need to break into... So we can say if we hit a number, everything previous becomes something, we put it in. A number. We just keep doing the number. And then when we hit something, if I have... So what I'm trying to say, is... Hold on. Because I'm already breaking it down. Because left parentheses, it can be a number. It's actually not that easy. Again, we'll not consider this. Right? This is if doesn't matter what it is, if I have a atom, right? Then we do this. But what if I have something in the stack? Like that's why I don't want to, because if I have something in the stack, then I have to like check the stack. Yeah, because but it should be, because I don't know when, okay? That's the thing. I don't know when I don't know when something ends. That's the problem. I do not know when it ends. Because I can be something and then I hit a capitalized letter. Alright, and now we say everything else will be handled. So I hit a capitalized letter, I need to check a previous. So if I hit a capitalized letter, if the previous have that and that, so I can handle, perfect. But it can also be the previous is a number, right? And I have a parentheses. Yeah, that is something I don't want to handle at this moment. The previous is a number, right? Then I shall just let's do the component first. So we say this is current. Yeah, we call it current. No count. Okay. So if this current dot append, okay, if it's this or this, or if it's larger equal to 0, and if it's smaller equal to 9, we all do it. Okay, we all do it. We all do it. Right, we just always append. If it's this, that means whatever is the previous need to be added onto the comps dot add current dot toString and current dot append f. We need to reset set length 0 and right. If it's a capitalized letter, then whatever the previous is, I need to add it. Right? I need to add it. Now it depends on if current dot size or length larger than 1. Right, if current length is larger than 1, we will do this. If the current length doesn't have anything, then we will just do this. Okay, that's good. Now if it's a left parentheses, then it's the same, right? If the current length is larger than 0, I'll push it in and I'll set it to 0. So yeah, so I'll say 3. Right, but once it's set to 0, I'm just going to say comps dot add, comps dot add f dot toString. I don't know how to turn char into string. String dot value of. Right, we put the left parentheses in. If we have something, we push it in. If we don't have something, we don't deal with it. So Aleph, it's a number. I already handle it. So now we can do else, right? Else if it's right parentheses, again, right parentheses, whatever the previous. So actually this actually can be else, right? This actually can be else, so we don't even need this. All right. So if it's a lowercase, so if it's digit, we add it to the previous. But what if the digit? Okay, but that's actually not right. It's okay. That is perfectly okay. We'll handle it here. We'll do an elif. Else if f is larger equal to 0 and f is smaller equal to 9. Okay, so it depends. If the previous one is already, then we say if current dot always going to be larger, right? If current dot chart, I can do this 0, is smaller than 0. Actually, no. If we check, it's always going to be larger. So we say if it's larger than 9, that means it's a, right? That means it's a string of none thing. So we always do that. Current dot set length 0 and current dot append f. Right? Otherwise we just append. Okay, so now we can do this. Right? Else, again, if current is larger than 0, so we have something, we always put it in, set to 0, add it. Doesn't matter if it's a left parentheses, right parentheses, does not matter. Right? So we'll do all that. Done. Okay. So now we have a component. Now we're going to go through the component. Okay. We'll go through the component and then we start putting into the stack. The component has 3 things. Left parentheses, letter, digit, right parentheses. Then we can do some computation. So we need a private str to number string num str. Okay. So what we're gonna do is go ahead one by one. Int res equal to 0. For char n of num str char array res equal to res times 10 plus n minus 0. Turn res. Okay, we have that. Very important. So now what we're gonna do is for component string C of comps, right? If C dot equals left parentheses, then stack dot add map dot of left parentheses 1. Okay. Else if C dot char at 0 larger than larger than 9. Okay, so this is an atom. Stack add map dot of C1. Else if C dot char at 0 is smaller equal to 9. Alright, that's a count. Then we'll pop whatever we have on a stack. So say map string integer count, go to stack.pop, because stack will always have something, right? And then whatever they have, you need to multiply by this value. Right, we need to multiply by this value. Then we'll say for string key atom of count dot key set count dot put atom count dot get atom times count and int num equal to str to number C times num, then stack dot add count if you had a number, else right param. Alright, if you have a right parentheses, then you have to pop everything until the left parentheses. Right, I have to pop everything until the left parentheses, combine them together, push it back in. Alright, we're gonna say map string integer count equal to new hash map while stack is empty and stack dot peek dot contain key left parentheses I think it's not contain. If it does not contain left parentheses, then how do I merge Yeah, I'm just gonna say map string integer temp stack.pop. Okay, we probably can do merge. We'll just go through the whole thing. For string atom of temp.keyset, we'll say count dot put atom count dot get or default atom 0 plus temp dot get atom. Right, we're merging them together. So we pop it out, put it into count, pop the next one, put it in count. So pop everything until we hit the end. Then we say stack dot if no, it gotta be stack dot pop because we have a left parentheses in it, which means this one is not even necessary because we'll always have a stack. Right, we'll push the left parentheses in it. So pop, this is pop the left parentheses. So I pop the left parentheses, right? And then this is the right parentheses, so we handle all of this. Then we say stack dot add count. Put the count in again. Okay. And at the end, we'll go through it one more time. Map string integer count equals new hash map. Oh, we do need that hash map for string atom of nope, while stack.empty is empty, right? Can we Java iterate through hash map? I don't know key sets value entry set. Okay, I can do entry set. So we can say for map.entry string integer entry get key. treemap.entrySet. Oh. Entry.getValue. Like that. Right? If it's not, I'll get a pop or get its entry set. We'll iterate through the entry set, and each one will put it into this. Okay, so this will be the same. Right, well, it's not empty. So what I'm gonna do is whole thing. Right, we'll go through the stack, pop it, get an entry set, put it into this. Well, pop. So this is not popping the left parentheses. This is just going to. Yeah, we don't even need this. No, we do. No, we don't. Because this one basically will pop it. Go through it, pop it, go through it. When it's empty, so we're done. Now we have a count, have everything. Now we need to sort. And then put it in. What are we going to return? We are going to return a string. Holy crap. Sorted. Okay, so Java. How do we sort keys in map? Tree map. A tree map. A tree map. So I either do a tree map or at the end we will do this. I think I'll probably just do this. It's easier. Tree map. New tree map. So can I do string builder result, new string builder, okay, for entry map.entry string integer entry of new tree map count dot entry set. Rest dot append entry dot get key rest dot append entry dot get value, but we need it to. Oh, I guess I can. Then we'll return rest.toString. Well, I guess. Let's take a look. Hopefully, at least passing these first few. Let's see if we're right. Unsupported. What? Immutable collections. Huh? How is count immutable? Atom count dot get keys. Key set. Right? Unsupported operation. Okay, let me see. Java map unsupported operation. This is specific. Maybe I'm changing. Maybe that's what I'm changing it. I shouldn't be. I'm just resetting. Oh, is that an update? Yeah, it is put. I don't know. It is put, right? Unless this is immutable. That might be the reason. It is immutable. Okay, we need to... New hash map. Okay, we need to use a new hash map. Okay, that's okay. That's okay. We'll say new hash map. That is about cannot be resolved to hash map. Any more hash map? Let's just do one. Make sure this one works. Because you go to the end, oh my goodness. Yes, components, right? Components, yeah, well, so a few things. This one will go here. Okay. Get components. No, breakdown. Ugh. And add a string now value. We should say if current, right? If it's a right parentheses, a left parentheses, everything will be current.append f. Dot length larger than 0. I should just add it. Comps add current.string. Okay. Same here. Components. We save this, we handle it. If it's this, we handle it. Okay, let's try it again. Really? There's no one? Oh, if it's 1, we don't show. Oh my god. Larger than 1? Larger than 1. I'd expect a lot of error instances. Holy crap. Oh, yep. Okay, current dot length 0. Oh my god. Alright, so 2 things. First, we need to say system. You know what? I think this will be better to. Yeah, we have to debug this. There's no question. Yeah, we have to debug this. This thing is way too complex. Not hard, but Lord, is it complex. Just string, right? So we don't need this, we don't need this. Num. Not num, it's a formula. What do we have here? MGOH2. All right. Oh, what happened? Oh, yeah. Good call. It's possible to extract method returning comps from a long surrounding method. Wow. Get string. Holy crap. Oh. Oh shit. Yeah, don't call it get string, just get components. And this will be get components. What's all this? Map dot replace all. Oh. Holy crap. Huh, yes. Map dot replace all. Okay, so now we're happy. Yeah, we happy. Let's put let's see the comps. It's correct. Okay. We go F8. Yeah, let's make this bigger. We can make this one bigger. That's okay. All right, F8. We have a new stack. Okay, if it's no, because the first one is MG, right? So it's false. That's true. Now we put MG equals, so have a stack. MG is 1, right? Stack MG is 1. Next, left parentheses. We put left parentheses in. Good, so we have this. Next is O. Okay, O is inside. Next is H. H is inside. Next is a right parentheses. Skip, skip, skip. Oh, shoot. Damn. My bad. This is my bad. So this has to be c.char at 0 is large or equal to 0, and an atom, a number. Okay, let's see if this one gives me the right answer. H, still not right. H2MG should be H2MgO2. We're missing some stuff. Okay, again, F8, Mg, left parentheses, O, Okay. Stack have 3, mg, left parentheses, o, and now is h, I think. H, done. Okay, h is in here. Next is right parentheses, false, false. Okay. Right parentheses, counter. Okay, it doesn't. Pop out the first. H1. So count H1. Next is wait a minute. Wait a minute. Why are you not popping this? Why are you not popping O? Oh, I put it in the wrong position. Damn. Okay, that was my bad. I put it in the wrong position. Okay, now let's try it again. H2. Okay, now it's right. Actually, I'm not sure. I don't think I set up everything, so I have to do this. Oh, this is annoying. IntelliJ is very good. Very, very good. Help me debug. Help me refactor. Okay. Okay. Yeah, I don't like this. Let me just put this one, put this function on the top. Handle the stack. This is the meat. This part, because this is just a merge. We shall be able to write a function called merge. Yeah, I want to further let's call it merge. How do you merge? So we merge two. Yeah, we'll merge two. We say private map string integer. But how do you merge it? It's multiple coming out. You don't know which one is. Right? Yeah, you know what? Nah, I don't think it's right. I don't think it's right. But I can put it here. Say 726. Not a hard problem, but very difficult to implement. I shouldn't say difficult, very complex to implement. Okay, well, run this one more time. If it's good, we'll try it. Hopefully we covered every case. Yes, we covered every case. Oh my goodness. My goodness. That is very complicated. Alright, I will read the solutions and yeah, we'll read solutions. I'll deal with this later. because I have something else to do. Okay, that'll be it. I will see you guys tomorrow. Adios.